Welcome to homework.
So in this problem, we're going to be drawing some Lewis structures. So for the first one, it's going to be GeCl4. So then count the number of valence electrons based off of the periodic table. So remember, the number of valence electrons is equal to the group number, or group number minus 10 if it's over 10. So we end up getting 32 electrons. So 32 electrons is just 4 groups of 8. So we're just going to put Ge in the center. And then we have chlorine bonded to the central atom. So for the next one, we have CO3, 2 negative. We have carbon bonded to oxygen. Okay, so then we're going to form bonds to the carbon. And remember, we need to add the charge on the ion into the electron count. So you can see here that with 24, that's 3 groups of 8. So we need to have 3 groups of 8 here. So we can't have a lone pair on the carbon. We're going to have to form one double bond to an oxygen. And we can't form any more double bonds because carbon can't expand its valence. So that's what we'll end up with. And then we'll have negative charges on the singly bonded oxygens. So then for the next one, that's the phosphate ion. So we have 32. So phosphorus is going to be the center atom because there are more oxygens in the phosphorus. And we need 32 because we had to take into account the charge when we calculated the number of valence electrons. So we already have 32, however, we can expand phosphorus's valence. So to minimize formal charges, we're going to form one double bond. So phosphorus can't really expand its valence anymore. And also you see that there's a charge of -3. So it would make sense we would have 3 negative charges. So that's going to end up being the Lewis structure, and there will be resonance between these single bonds. So for D, this is the peroxide ion, and you see there are 14 electrons because we have a charge of -2. So we cannot form a double bond between these like we do in molecular oxygen because of the electron count. So we have 12 non-bonding, and then we have 2 in the bond between them. So that would be the Lewis